Let's now talk about plotting some circles. A circle equation is y squared plus x squared equals 4. So let's plot this on the graph. Again, we don't know what we're doing, so let's put some tables of values. Oops. Let's write a table of values here with x and y. So if I plug in -1, -2, 0, I should put that the other way. -2, -1, 0, 1, and 2. What do I get when I get this? So let's plug in our numbers. -2 squared, so it's going to be y squared plus -2 squared equals 4. Oops, that's right. That's right. So let's solve for y here. This is going to be 4. Bring the 4 over is going to be 0, so that y equals 0. But let's, before we do that, let's just solve for these instead. Let's just write them out first. So we have y squared plus -1 squared equals 4, and y squared plus 0 squared equals 4, y squared plus 1 squared equals 4, y squared plus 2 squared equals 4. So let's solve these again. And so we take the -2 squared is 4, bring it over, is going to be a -4, so y squared is equal to 0. Therefore y equals 0. Then we have -1 squared is 1, bring that over, becomes -3. So y squared equals, positive 3, because this is positive, bring it over. So y equals plus or minus √3. Then we have y squared plus 0 is equal to 4, so y squared is equal to 4. So y equals plus or minus 2. And now we say we have the next one, so 1 squared is 1, bring it over, becomes -3, or positive 3, so y squared equals 3, y equals plus or minus √3, and y squared plus 2 squared is 4, so it comes back to 0. So again, we're sort of repeating this pattern. Y squared equals 0, y equals 0. So let me, I'm just going to erase these equations so we can just have this little table of values while we're plotting. So we have 0, plus or minus √3, plus or minus 2, plus or minus √3, and 0. Let's plot this. So we have a few points here. Let's say this is 0, this is √3 negative, and this is -2, and this is √3 positive, and this is 2. So, and we'll plot our lines here, 1, 2, -1, -2. So when it's -2, we have 0 right here. I'm going to draw a different color marker. -2, we have 0. At -1, we have plus or minus √3. So when x, oops, that's backwards. My mistake. So let's call this √3 and this minus √3, and this is 1, -1, plus 1, plus 2. So at -1 in the x, which is why I had to change that, is plus or minus √3. So we have a point here and a point here. Now at 0, we're going to have plus or minus 2. So we have this point and this point. And at 1, we're going to have plus or minus √3. And at 2, we're going to have 0. The reason this sort of looks like a diamond is because √3 is actually a little bit bigger than 1. So it should be a little bit raised to be somewhere about here, somewhere about here, somewhere about here, and somewhere about here. And that forms our basic circle shape. Oh, up to 2. Forms our basic circle shape. So that's how you plot those graphs on there. You may be asking, what's the easier way to do this, rather than just plotting out values? The easy way is to say y squared plus x squared equals r squared, where r is equal to the radius of the circle. So all we have to do here is say y squared plus x squared equals 4. So r squared must be equal to 4. So the radius must be equal to 2. So all we do is plot our points. Our middle is 0 here because there's no translation in the x or y. And then our radius is 2, so we just draw a circle around with a length of 2. And that's the easiest way to draw it. Let's talk about if there's any sort of translations here. Such as y minus a squared plus x minus b squared equals r squared. So all we have to say is that if we have a negative a here, a is the translation in the y, b is the translation in the x. So if this is a positive number and this is a negative number, we're going to have the opposite numbers. So this will be a negative a is the vertical translation. So we'll go down a, negative a, and negative b. So this would be our center of our circle, and it would just make a circle around that point with a radius that's equal to r. So that's how you graph circles.